next presenter is Edward Kim. So Edward is from Waco, Texas, and in addition to playing the violin and tennis and solving puzzles, Edward is a really good scientist. So Edward, are you all set here?
I am.
All right, let me give you your presenter tool. Best of luck, have fun.
Thank you. Hello everybody, I'm Edward Kim. And gosh, this is difficult. And this is my innovation, the portable grass waste air cathode fuel cell. So when I was mowing the lawn, I realized how much grass was going to waste. And that really inspired me to think, you know, we have an energy crisis, and we have a problem with CO2 emission, or pollution, and I have all this grass waste. Could I somehow combine all of this together to use grass waste to create electricity? And that's what led me to my innovation of the grass waste fuel cell. So what's a fuel cell? What's the science behind it? Well, a fuel cell is, it's a device that produces a continuous current of electricity from a chemical reaction. And so in this case, you have H2 gas seeps into the catalyst layer, and it will separate into its parts. So you have 2 electrons and 2 protons, and the protons will flow through the PEM membrane, the proton exchange membrane, and the electrons will flow through the wire. That's because the PEM will only allow positively ionized positive ions to pass through, leaving the electrons to flow through the wire. And that's the electricity, the electrons flowing through that wire. And at the end, you get a byproduct of H2O, which is very eco-friendly. So I thought, and my hypothesis became, that I could use this grass waste in a fuel cell to create electricity. How? Well, in grass, you have different systems, such as the cellular respiration or the photosynthesis, which has hydrogen or H+ pumps, hydrogen ion pumps, and also electron transport chains. So I thought those are the materials necessary to power a fuel cell. Couldn't this work? And so I tested it, model number 1. So I have all this grass waste, and then I put water on the other side to have the oxygen, and I put it together and thought, wow, it worked, 135 millivolts. I was excited. I just put grass in a container, and I got this energy. So I thought, well, can I connect this like a battery and improve that voltage? And yes, it worked. Model 2, I made one, connected, and I could see it added on and on, the voltage. And that was really exciting. But another thing to consider is, what is the other element to power output? You have volts, but now you have amps. And I didn't really look at the amps much, so I decided to check. I was pretty disappointed. But that's okay. That didn't discourage me. That just made me think, how can I improve this? And so that's my model 2.1. I decided that there was a limitation to the amount of electrons being accepted. And I changed it to a metal anode brush, which had a larger surface area, meaning that it can absorb more electrons. And that led me to my final innovation, model 3. Here, the biggest improvement is the air cathode system. 3M was able to provide me some amazing materials. And one of them is the CCB membrane. And that's very important because it absorbs the oxygen from the air instead of me having to put water, a separate container. And then there's also the PEM membrane, which was a very thin, clear membrane that you can put right before that. And it was really effective, which was great. And then I also used VHB tape to put my pipe together. Also the brush anode. So this is me constructing the model, and we designed it together with my mentor, Dr. Chris Thunhorst. And so what are the things that I tested throughout this whole summer, whole program? Well, I tested the age of grass, amount of grass coarseness, and by the way, all of these had their own hypotheses. These are all separate experiments. And so the red ones are the ones that most affected the power output, such as the change from that carbon patch to that brush, also a change between PEM and salt bridge, also the distance from this anode to the CCB electrode. Also, what's the final performance? Well, I got 1.5 volts. That's incredible. That's equivalent to an AA battery. And I got 4 milliamps. That's 200,000 times better than Model 1. 200,000 times. You can see on the comparison graph, I can't even see the values before. It's on a whole new scale. And finally, this is compact, and it's portable. And you can walk around with this. You see some grass waste lying around, put it in, and you got electricity with you wherever you go. And I think that's the magic. So I'd just like to say thank you to my mentor, Dr. Chris Thunhorst, and also Discovery Education, 3M, and everyone who supported me. Thank you so much.
Edward, that was absolutely outstanding.
Thank you.
I now have motivation to mow my yard more frequently. On a more serious note, I was just curious, if you were trying to take this technology and to try to use it on a more continuous basis, can you envision an approach where this would be something that you could be using day in and day out?
Definitely. I can see so much future for this, so much possibility. Because all you're doing is putting grass waste into a small container, PVC container, and you're creating electricity. And definitely I can see the implications of using it in everyday life. Already, according to the data values, it can be applied to light an LED. And so you can carry it around. You need energy. You can carry it too, if you want, in your backpack. And then you can power more than you want. And yes, I can definitely see its applications.
Did you do any research on other inventions that are similar to this?
Well, this might be a little arrogant, but I think there's nothing similar to this. But yes, I did do a lot of research. That was the key. This was really hard. It's like trying to create something, it's like trying to create energy out of a rock. I mean, how are you supposed to do that? Definitely research was considered. Fuel cells, what's a fuel cell? That was considered. And also other different types of fuel cells. That was very important too, to look at how they develop their understanding of fuel cell to create their own types of fuel cells. And that's how it led me to this.
Edward, what was the most difficult part of this process for you?
Well, the most difficult part of this process was improving and improving and persevering even when it seems like it's low. Really, I think when I started off and when I look at my past, you know, the values were really low looking right now, but I was still inspired then. And I think that's really important. Even if it's low, you should still see the possibilities in it. And right now, I made it so that it's applicable. I think that's really special. And the most hardest part would have been to keep on persevering and keep on thinking in different ways to create this innovation.
So what other tests do you think you would need to do in order to further this research and make it available worldwide?
Further research is definitely necessary in different aspects. Right now, the fuel cell, I created one, but I still haven't, I created, like in my Model 2, in my original model, I created series and connected them. In this one, I have one, but definitely I can create more. And so in further research, I would connect more, hook them up, see if I can manipulate the power output. And definitely, one important part is to understand the principle behind what's happening. And that's another thing that really needs, I guess, clarification. So further research.
Edward, you made what might be a very complicated process seem very simple, and I'm having a little trouble understanding exactly what the catalytic process is. Can you explain that? Once you put the grass into your innovation, what happens there to exactly separate those electrons and create the electricity?
That's a very good question. So what really happens in this fuel cell is that, like I mentioned earlier, grass waste has proton pumps going around, and so there's proton all over this water now because, you know, I put the grass waste in this water. And then also you've got these electron transport chains. These electron transport chains have high potential, and that's really important. That potential to donate itself and create that electricity, that's very important. And fuel cells normally work off of oxidation, and in this case, the oxygen is very important. The oxygen is at lower level, and then the electron transport chain is at higher level. And naturally, just like in real life, you want something to fall down, or things they'll fall down. And in this case, the electrons would be falling down into this, trying to meet this oxygen, and then the reaction will create H2O as a byproduct.
Edward, I'm curious, how long does this electrical output last? And so at what point do the clippings, like, don't have any juice in them?
So normally I just use a fistful of grass waste, and that seems to be the optimum. Also, I mean, consumers aren't going to consider, 1.5 liters of grass waste. No, oh, I'm sorry. Thank you.
Excellent. Nice
Thank
job.
you.
That was fantastic.
Thank you.
I'll take that.